Hi, welcoming you all for this video tutorial on tree data structure. In this tutorial, we are going to see what is the tree data structure, the components of the tree, the terminologies that are used in tree data structure and binary tree. To start with, the definition of tree data structure is that tree data structure is a non-linear one and it is used for representing data in hierarchical manner. Hierarchical in the sense it can be represented level by level. For example, you can consider the structure of an organization where you will have the managing director, then you will have the manager, then you will have the department heads, then you will have the employees in each department. Or you can consider a family tree. In the family tree, we will have our grandparents or great grandparents, then we'll have our grandparents, then we'll have parents, then we'll have children, and then we'll have grandchildren. So these are represented using level. Okay, so the family tree can be considered as an example for representing data structure in a hierarchical manner. And the tree data structure has few properties. It has root node, it has parent node, and edge. Root node is nothing but in every tree there will be one node which is called as root node. The tree originates from this node, and this root node will not have any parent. So from the diagram you can see the red one, which you have the single node on top, that is referred as the root node. Next one is parent node. So each node will have one parent, but it can have any number of children. Okay, so there will be only one parent which is available, but the children can be more than one. And edge. So here from this diagram, you can tell like the last level of node, red and yellow are children of blue node. The blue node is known as the parent node here. Then next one is edge. So all these nodes are connected via this edge. Or you can tell like each node is connected to its children through edges. Okay, the next one is components of tree. We can tell like a tree is a collection of entities, and these entities are called as nodes, and these nodes are connected by edges. So here in this, from the diagram, we can see like A, B, C, D, E, F and G. All these are nodes, and all these nodes, like each node will contain value or data, and the nodes may or may not have children. Okay, so having children is not a mandatory one, so it depends. So all these nodes are connected through the lines, or you can tell it as links, called as edges. So the node A here is called as root node. Okay, and you have something called as subtree. Subtree is a part of a tree. It's not tree is referred as, the whole tree is referred as a tree, but a portion of the tree where you will have a root node or parent node and some children node, this is called as a subtree. So from the diagram you can see B, E, F are subtree, where B is the parent of E and F. E and F are children of B, and E and F does not have any children or subnodes, so they are also called as leaf nodes. The nodes are the last level. Here from the diagram, the last level is third level. So from the nodes, the third level does not have any children, and they are called as leaf nodes. So each node can be referred as a node or a vertex. So all these nodes are connected through edges. Okay, so you have here A, which is the root node. Then next we'll see the terminologies of tree. The first terminology is predecessor. Okay, predecessor can be in any level. Okay, so predecessor is a node which is above a particular node. So from the example, the predecessor of E is B. Okay, and here predecessor of B is given as A. So B is in level 2, A is in level 1. So whichever node is above a particular node is called as predecessor. Successor node is a node which is below a particular node. So here we can tell like B is the successor of A, C is the successor of A, D is successor of A, and G is successor of D. Okay, so the node which is below a particular node is called as successor. Then we have ancestor. Ancestor is like from the current node, okay, to the root node. The full path is called as ancestors. There's all the nodes that is before a particular node, the same path, that is known as ancestor. So here in this, from this diagram we can tell like E, ancestor of E is B and A. So all the nodes above that particular node. If you consider G as, if you want to know the ancestor of G, then the ancestor of G is all the nodes above it till the root you have to tell. So all the nodes above G are D and A. So ancestor of G is D and A. Okay, then descendants. Descendants and successor, we can tell it as a similar one. But descendants are nodes which are after a particular node, and it should be in the same path. So here descendant of B is E and F. Descendant of D is G. Okay. The next is parent predecessor. Okay. Parent predecessor is one level which is above the particular node. So here parent of E is B, parent of C is A, parent of G is D. Okay. Then sibling node is like a node which is in the same level and which is having same parent is called as sibling node. So here E and F are sibling node because E and F are having same parent B. So E and F here are called as sibling node. Then last one is degree. Degree is nothing but number of children in a particular node. So here you can see like C does not have any degree because C does not have any children. Node degree of node B is 2. Degree of node D is 1. Degree of node A is 3 because A is having 3 children. Okay. So degree is nothing but the number of children in one node. Next we'll see about binary tree. So binary tree is nothing but a tree which has in which a node has at least two non-empty subtrees. It should have at least two non-empty subtrees, not more than that. Okay. Set of nodes T is a binary tree if either of these is true. In the sense like T, a node can be empty. T refers to a node. A node can be empty and root node should have only two subnodes. Binary is 2, so it refers to two subnodes. Okay, so here root should have only two subnodes and each node should have only two subnodes. So you can tell the whole thing is a binary tree. See, from this example you have dog as the root node and it is having two subnodes like cat and wolf. So again cat is the parent of canine and it is having an empty node. Okay, it doesn't like it is an empty node there. So each node in a binary tree will have two subnodes or two subtrees. Next we'll see the examples of binary tree. The first example of binary tree is expression tree. So expressions can be represented using binary tree. So here you will have the internal nodes and the external nodes or the leaf nodes. The internal nodes are will be represented using operators. The leaf nodes are used for representing operands. So here you have four leaf nodes. So here 1, 2, 3 and 4 are leaf nodes, and the inner node or non-leaf node, like where it is it will be used for representing operators. So I have from the example given in the slide, we have an expression 1 plus 2 into 3 minus 4. So 1, 2, 3 and 4 are known as operands, plus multiplication and subtraction we have operators. So all these three operators are represented in a non-leaf node or an inner node, and 1, 2, 3 and 4 are represented in the leaf node. Next example of binary tree is Huffman code. So this Huffman code is used for representing characters uh, which are appearing in a file or a stream. Okay, so your Huffman code may use different number of bits to encode different characters. See, this is represented as a tree. So all the characters, it can be an ASCII or Unicode, which are used for fixing number of bits for each character. So we can represent the Huffman code using a binary tree. The next one is examples. Another example of binary tree is binary search tree. Binary search tree is nothing but a binary tree plus a condition you have. Binary tree is one which is having two subnodes. In this binary search tree, the elements of the left subtree will always be less than the element of the right subtree. Okay, so for it is considered for each node. So when you're considering the data of each node, the left subtree will be a value lesser than the parent node, okay, and the right subtree will be a value greater than the parent node. So here you have the root node which is represented using the value 30. So all the nodes on the left side of the root node will be having a value lesser than 30, and all the nodes to the right of root node will be having higher value than 30. So here you can tell like 15, the subnode of root node is 15 and 60. So left side is lesser than root node and right side is 60. So now 15 is the parent of 7 and 22. So 7, which is on the left of the node value 15, is lesser than the node, that is the parent node, and the node which is on the right side is greater than the parent node. So for each node, this condition will be followed. Like each node will have only two subnodes, and in this the subnode which is on the left will be always lesser than the parent node, and the right subnode which is on the right will have a value greater than the parent node. Thank you all for watching this video tutorial on tree data structure. Bye.